Hi, good afternoon.
Good afternoon.
Okay, so today's session is week 11 open session, right? Yeah. So I think a lot of basics is there from statistics 1 and statistics 2. Majorly, I think from statistics 2 because joint PDF of discrete and continuous random variable are there. Just a minute. Okay, so what do you expect from this session? So, do you want to recall the concepts, and or maybe I should take some questions directly from activity or practice assignment? And uh, I don't know, like you guys have seen
Maybe
the.
we should first recall and then we can do some questions because I haven't gone through lectures to be honest.
Okay, okay, fine. So, yeah, but maybe let's go through the some concepts. Um, just give me a minute, then maybe. Is it okay that if I take one question and then based on that question
Yeah,
if
sure,
I
sure. That will do, but
maybe
Yes, sir. That will be better.
yeah, because I don't know, because there is no theory continuous theory as such, right? Like
yeah,
previously we have seen like we have some theory associated with it, but okay, maybe this is better, I guess. Maybe I'll take some question, and based on that question we'll discuss what is there, right? Okay. I think the probability space and conditioning, that I think that is very basic, right? Shall I skip that and directly go to random variables, and then we'll take some examples from expectation.
Yes, sir. Yes, sir. Yeah.
Okay. So random variable, right? Like how the what is the range of the random variable? How that will be defined? What will be the probability distribution of random variable? If you are familiar with that, maybe we can directly start from there itself. So my screen is visible, right?
yes, sir.
Yes, sir.
Right. Okay.
Sir, can you start from random variables?
Okay. Maybe I'll start with one single random variable, then we'll move towards multiple random variables, discrete and then continuous, right? That
Your
is,
screen is off, sir.
yeah, I'm just opening this.
Sir, just a question out of the context of this
Hmm.
week 11. What will be the end term weightage in approx terms?
Okay, I have some okay, maybe at the end maybe I'll talk to you regarding that. Just remind me once.
Yeah,
Maybe
sure, sure, sir.
I'll talk about that.
Because, sir, I have not done too good in the first two quizzes, so I'm
Okay.
planning to excel this one. Yeah.
Sure. Okay. Sure. Maybe I'll talk about that at the end. Okay. Okay. So actually, week 11 is mostly related to continuous random variable, conditioning of the random variable, expectation, and multiple. Okay. So independence, transformation of random variables, and mostly it is talking about continuous random variable. But before that, we have a recap. So maybe I'll go through that recap first, and that will start maybe uh, with what is single random variable. Then we'll dive into multiple random variable. Well, I'll just see if any good question is there. Yeah. So okay, maybe I'll talk a little bit about what is a discrete random variable and how that uh, discrete random variable will have the probability distribution. Right. This screen is visible, right? Maybe this
Yes,
is
sir. Yes, sir.
okay. It's fine. So what is random variable? Random variable, and maybe we'll talk about a single random variable with single discrete random variable, right? So let's say I have tossed a coin. Okay, I have tossed. So my experiment is experiment is experiment, experiment or trial, right? Maybe I'll talk about maybe this is the experiment. My experiment is I have tossed a coin, tossing a coin, maybe tossing a fair coin.
Are you writing something?
Yeah, is it not visible?
No, no, not visible.
Okay, yes. I didn't share my entire screen. Fine. So okay, this is visible, right?
Yeah, it is visible now.
Okay. If I toss a fair coin, what will be the outcome of this tossing a fair coin?
HT.
1/2 and 1/2.
No, that is the probability associated with. Outcome is
Head
I'll
and
get a head
Tails.
or I'll get a tail, right? I okay. So this experiment, okay, I have said that this is an experiment tossing a fair coin, and I'll get a head and tail. And since it is a fair coin, what does that mean? Fair coin means the probabilities associated with each of the
Equal
outcome
probability.
is equal, right? So here we have how many what is the outcome? So this is defined by sample space, right?
Yes, sir.
Sample space is all the events or all the outcomes of a experiment or of an experiment, right? So in this experiment I have two outcomes, which is one is head and another one is tail. And since this is a fair coin, I will have the probabilities associated with them as 1/2 and 1/2. Okay, so this is a simple experiment, two outcomes, and this is the probability. Suppose I have defined a random variable x such that uh, getting ahead uh, in one toss of a fair coin, right? If this is my random variable, okay, this is a single random variable. Uh, okay, in this context, what do you think? Getting ahead is what? It's a success, right?
Hmm.
Right,
Yes,
it's
sir.
a success. And in one toss, if I'm getting ahead, that means and I arbitrarily chose two values to this random variable. Suppose I've chosen one for success, okay, and I have chosen zero for a failure.
Yes.
What does the mean by success here?
Getting ahead.
Head, okay, and what is the failure?
Tails.
Tail, right? Okay, so what values my random variable is taking here? 0
0 and 1.
and 1. So if
So
I
X is indicator random variable.
yeah, you can say that, yeah. So here indicator, yeah, correct, you can say that. Anyway, it is related to switch only, but fine. But here in this case, but these are assigned arbitrarily, okay. So 0 and 1 are my values taken by a random variable. What is the probability associated with this?
1
Probability
by
is
2.
equals to, yeah, this is 1/2 and 1/2. This is what is called a probability distribution.
Distribution.
Okay, this is a probability distribution of a random variable. Fine. Now this probability distribution I can write in another way. It's like this: probability that x equals to small x. Maybe you have seen it earlier in stats 1, stats 2, that this is probability that x equals to small x is equal to 1/2 when x is equals to uh, sorry,
0.
yeah, x equals to 0, and 1/2 when x equals to 1. This is the simplest experiment and simplest probability distribution uh, shown here, right? Now is it okay that if I define this or maybe if I represent this one as success and minus one as failure here,
Hmm. Maybe yes.
Yes, sir.
right? This is possible, right? Okay, this is okay also because it doesn't change anything, because anyway I'm saying that when I'll get one, that means I know that I'll get a head, and when I say minus one, that means I'm getting a tail. That is true. But what will happen? Okay, another property is expectation of a random variable, right? Expectation of a random variable. What does it say? Expectation is nothing but what? It's an average, right? Average of long
Long
term average, right? Right. So suppose I have 0 here. What will be okay in terms of discrete random variable? How I'll define expectation of x as summation of
x into
x
fx.
into
P of
or
x.
yeah, maybe yeah, I can say like this, or this is also fine if you guys are okay with these notations. This is also fine, right?
Correct.
It's fine. Maybe I'll write this as like this. Both are equivalent only. Okay. In this context, can you tell me what is the expectation of random variable here?
0 into 1 by 2 plus 1 into
0
1 by
into 1 by 2
1 by
plus 1
2. 1
into
into 1 by
1 by 2, right? Because x is what the value taken by a random variable. So and I'm just going to do the sum. So 0 into 1 by 2 plus 1 into 1 by 2, and this is nothing but 1 by 2, right? So I'm getting this. So if I draw a graph here, what will happen? Suppose I draw a graph. Suppose this is value 0, this value 1, and on y-axis I'm having probability that x equals to small x, and each of the probabilities half I know. So this will look like this, right? Maybe this, and this is what PMF, right?
Hmm.
Probability mass function. uh, where do you think the expectation of x is lying here? Exactly in the half portion, right? So, and it is evident because the probabilities associated with each of the value taken by random variable is same or similar, same, right? So it is half and half. But suppose let's say I have changed this arbitrary value to -1. What will happen to expectation of x now?
It will be 0.
It will be 0. Okay, it's -1 into 1 by 2 plus 1 into 1 by 2 equal to 0. Is it correct or is it wrong now? So initially I had 1 by 2 as expectation of a random variable. Now it's 0 here. Is it correct, or is it giving me the wrong intuition or something else?
Sir, how
Seems
can
like
it is possible? Like,
Because it is dependent on what, how I'm defining a random variable, or how I'm assigning the values to that random variable, right? So when I assigned value 0, it was what, failure, right? Which means I said it's tail, and this is success, which means it was getting head. Now instead of that, I'm just doing -1 and +1, right? And this is probability that x equals to small x, which is again nothing but 1 by 2 and 1 by 2, right? So 1 by 2, right? This fine. This is also PMF, but only what changes here? 6, right? But still you can see where is 0 lying here in this case,
in middle.
again in the middle, right? So actually these two are same only, right? Because the only thing, uh, the value you are seeing is different, 1 by 2 and 0, right? But that doesn't make any change into the intuition, right? So this -1 is what, again it's a failure, right? And 1 is success.
Sir,
Yes.
the way you've defined the function, like
Hmm.
the way you've drawn the graph, isn't this done for a continuous function? But like for a discrete function, it should be like it shouldn't be like a shape like a rectangle, right? It should be just two lines. Or am I wrong?
Yeah, it's that's why I just shown it in a dotted way, right?
Okay, okay,
No, whatever you said is correct only. These two only, the just I'm just showing it like the value, right? So I'm just showing
okay,
like this.
okay.
It's 1 by 2. Each of the random variables taken. You're saying is correct only. Okay, these are the dotted lines, just to represent that okay, both the values are same, nothing else. But this is clear now. So as you give the values to your random variable, accordingly your expectation value will change,
So in the
right?
second case, the expected value is still it is 1 from the graph.
No, it's 0 na.
No, from the graph, because the
How?
height is half
Hmm.
and the width is 2. So the area of the graph is still 1. No? How does it, the area will be becoming to 0?
Okay, how? Okay, you are saying that expectation of x is what you are saying. Is it a area under the graph you're saying?
Area under the graph is 1,
No,
not 0.
but area under the graph is valid only when your function is continuous, right? This is a discrete uh, function, right?
Area of this is also 1 actually, right?
Yeah,
Like
but
2 and 2.5, right?
but what I say is maybe this area will not
But
be
this is
applicable
discrete
for
case,
this.
so
Yeah, correct, right? See, okay,
But
this is
it's
anyway,
valid for
it's got to be
continuous
different from the first graph. No, there is no change in the graph except the value of the axis. Everything is same.
it should be same, right? Because the both the things are same only. It's just I the way I have defined the failure and the way I have defined the success is different, right? Here I
How do I
represent
see the zero there? In the second graph, how do I see the zero?
here on the x-axis,
Hmm?
because the expectation of x, it's a function of x only, right?
Yeah, that's okay in the equation, right? But how do we see in the graph that is zero?
I,
It should be, what sir is trying to say that the expectation will be right in the middle of the all the values.
yeah, that's what I'm saying. This I'm saying that this is the value, this is the expectation of x, right? Like the value expectation of x is, this is the value, and this value is at the like middle of these two values, right? -1 and +1. And why this is happening? Because the probabilities associated with these two values are same, right?
So we could have taken -2 and +2 also.
You can take, see, if you, so if you are taken -1 for what, let's say for failure or maybe getting a tail, and 2 for getting a head. See, just don't get confused with this anyway. I'm just showing you like this can be, this is possible. This is basic thing, but maybe a lot of people, because eventually will have that 0 1 2 3 4 5, or maybe if you roll a die you will say 1 2 3 4 5 6 as my values to a random variable, but I can take any value. That's what I wanted
So
to
only
show.
the midpoint is the expected value.
Right, that's true,
Okay.
that's correct.
Okay.
Because the way you're saying, when you do the integration, right, and that area under the curve is nothing but the integration under, or area under the curve, correct? But that will come only when your function is continuous, right? And that we'll see later on, maybe after some time. So okay, this is currently, this is the case. So now what do you think my value should lie in this case? By now with the intuition, what do you say? Right, if this is true and this is -1, what do you think my expectation will lie?
1.5.
1.5.
1.5.
0.5.
0.5, right?
0.5, 0.5.
0.5, right? Correct. Okay, all of you are okay with this? Because see, the distance is 3, right? And if you do it half, so it should be 1.5 time, like away from 2, and minus like 1.5 away from -1. So you can just
Like
do the
given
calculation
that it
also.
would have been 2 minus 1 upon 2.
Yeah, anyway you can do that. So this is like uh, right. Okay, okay, this is fine. So this is one thing. Later on maybe I'll have, what else is remaining? Variance of x. So variance of x is what? Is expectation of x square minus
Bracket square.
the, okay, this is all we are defining for uh, this is the way we are defining for single random variable, right? This is the, and how to find expectation of x square now in this case?
X square into P of X.
So expectation of x square is nothing but summation of x square into probability of,
Yeah.
okay. So yeah, 0 square into 1 by 2, 1 square into 1 by 2. Again, if you see, it is 1 by 2. Expectation of x square is 1 by 2, and I know what is expectation of x as, it's 1 by 2, right? Okay, now variance of x will be equal to 1 by 2 minus 1 by 4. It's nothing but 1 by 4. This is the variance, and then we have standard deviation, which is nothing but variance of x, right? So this is root of 1 by 4, which is 1 by 2. Okay, This is a simple case for which we have seen the probability mass function, then what is the expectation of that, and what is the variance of this. Now, if I take one more example, let's say, okay, now we'll take one example from activity question maybe.
Sir,
So,
SG is under root variance of x, right?
yes, yes, correct,
Fine.
right? Standard deviation is root of variance of x. Okay, so these are all basic definitions. One more thing is, let's say, what are the properties of PMF?
Sum of all PF should be
First of
positive.
all probabilities should be
Positive.
greater than equal to zero, right? They can be zero, yeah, that means positive or zero. And
Non-negative.
yeah, and second is
Sum of all that would be equals to 1.
equals to 1.
1.
So this is the these are the probabilities of probability mass function, right? Okay,
Sir, but
yeah,
what is the definition of a random variable? Like a variable whose value is not known beforehand. It could be anything.
okay, okay. Just tell me what is the definition of variable.
It could be anything. Like it's something that changes, right? Not no fixed value.
So let's say we have one container, and we are getting anything, right? So for example, uh, uh, if you have seen the data science or maybe anything, right? So let's say some variable is, I have defined one variable as x, right? And I'm saying that
Yes.
there are uh, maybe I define as so okay.
So, sir, let's just say if there's a question, right? It
Huh.
says that number of head, like number of coin cost we need to get a head.
Hmm.
Then it is a random variable, right? It could be
Yeah,
2, 3. It could be 3, 6, anything, right?
random variable means that variable is generally what it is, the value which is varying, right, or it is
Yes.
changing, right? It's not
Yes.
the same. But random variable is you can get any random value but within that range. Again, the
Okay.
range is
Okay.
very important, right? So it should be
Okay.
within that range, but it is getting anything. Like for example, if you wanted to see like what value, or maybe let's say I have tossed coin 10 times, right? So in the first toss I may get head, I may get tail, right? Similarly in the second
Okay.
toss I may get head or tail. So
So it's like number of heads that we can
yeah,
get,
so
right? That would be
how
random.
can you can define the random variable as like however you want to define. But the thing with random variable is, even though the values are random, but the outcomes of that experiment should be, the unique maybe, or maybe you can say that there will be
Okay.
properly
So
defined.
it's not fixed. It could be 2 or 3, or it could
It
be
can be
anything, right?
anything, right? Yeah. So if you wanted to see how many heads I'm getting in 10 tosses, right? So they can be anything, right? So if in the first 10 tosses you'll get 3 heads, maybe in the next 10 tosses you'll get 4, maybe in the next 10 tosses you'll get 0 heads. So that 0, 1, 2, 3, right? It's not coming 0 after 0, it is getting 1 after 1, it is getting
Yes.
2.
Yes.
It's not like that. So in case of in terms of variable, what is happening, will get various values but one after another, right? Again it is but in case of random variable you'll get any random value, right?
Okay.
So yeah, yes. Okay, so maybe we'll see one problem here. So let x be a discrete random variable with the following PMF. So this is the PMF given. So can you tell me first of all, is it a valid PMF?
Yes, sir. Like
Okay,
most.
okay, but you can't say from here. Okay, for this question
Third one
three,
is not
yeah,
not
for
a
question
valid, right?
number
Which
three,
Not valid. Third one is not valid because it has
why?
minus instead of
Minus.
it.
Minus.
Okay. What about question number 5?
Uh,
It's a valid, but
one,
yes,
two,
a
three,
valid.
four. Yes, sir, valid.
Right? Why?
Yeah.
Because you have
All are
all
positive, some
probabilities
negative one.
positive or maybe non-negative, and the sum of all the
Two
probabilities
plus
equals to
one.
1. So zero point 0.1 plus zero point 0.2 plus zero point 0.2 plus zero point 0.3 plus zero point 0.2 is equal to 1. So here we have given that this is a valid PMF, and I need to find the value of k. Can you find it out? Like how can we find it out?
We add
We'll
k's and
just
put them
add all
equal
the
to
k,
1, right?
equate it
Yeah.
to 1, and then find the value of k.
So can you just find it out? Like what is the value of
Yes.
k now? Yeah.
Sir, can you please zoom in?
Okay. This one.
Yeah.
Okay, what is the value of k?
Give this.
Okay,
-1. -1 and 1 by 20.
But
so
-1 is not valid.
-1 is not valid
1
because
by
if I
20, 1 by
multiply
20.
it, yeah, if I
-1
multiply
and
with
1 by 20.
-1 is not valid because
So it,
if I
yeah, okay.
if you can multiply with this any value,
It's
that
not
will
even
be
in the options.
1
So
by
it's
20,
not.
sir.
yeah, yeah, right. Okay, fine. So this is okay, right? Maybe let's talk about uh, uh yeah, uh, function of a random variable, right? Function. So y is a function of a random variable. So okay, can you tell me what is the range of y now? I think this is very easy. So y is equals to
0,
x
1,
square
4.
0 to 4.
0,
1,
but
4.
One
yeah,
0, 1, 4.
0, 1, 4.
0, 1, and 4, right? And what are the probabilities associated with 0,
0.2.
0.2,
with 1,
0.5,
0.5.
right? And with 4?
0.3.
0.3.
So everybody understand this, right? Or do you like, if
You
anybody
added
have
that.
doubt, if you have a doubt, I'll show you like how to find the probability.
Sir,
Because you can,
like in week 11, the concepts are as tough as they were in stats 2. I mean, as complex the questions, or
yeah,
are a bit easier. Okay.
yeah. So if I say it, not that much. 11 is fine only. 11 is not. Maybe week 12 will be
Like
somewhat.
if I cover all the concepts from week 11 and I don't need to go to like stats 2 to like
No,
go
I
back
don't
to
think
stats
so.
2.
I don't think so. It's needed. That will be fine.
Okay.
sir, but week 11
Okay.
is 2 weeks, sir.
It's not 2 weeks. It's like, see, recap of week 11, right? It's just like discrete random variable. I think that is very. It's not difficult, right? As you see, it's like whatever you are seeing. It's maybe you guys know it earlier. It's just like we are revising it because somebody like maybe you have forgotten some things. Otherwise, week 11, the recap of week 11 is not difficult. Week actual week 11, there are some things. Maybe I say. Uh, Independence also. I don't think so. It's
So
again this.
I have one question.
Yeah.
This one. How did you say that probability of 1 is 0.5? Whether you
Okay.
added
Yeah, yeah. So you can actually. So how come you said range is okay? Let's say range is 0 to. Okay. Let me write it down. So y is what? Y is a function of a
y is
random
x
variable.
square, no? So you just put the value of x and you will get.
Yeah. So here you have these values, right? This was the range of x, right? So 1 and 2, right? And what is the range of y? So after putting each of this value, I'll get 0, 1, and 4,
4.
right? So when I say, if I wanted to find probability that y equals to 0, that means probability that y is what? X square, right?
X square
X
is
square equal to 0, right? So probability that x equals to 0. So what is probability that x equals to 0? It's, I think, 0.2,
yes, sir.
right? Okay, if I wanted to find probability of y equals to 1, what does that mean? Probability that x square equals to 1. And if I take the square root, it will become plus 1, or
And minus 1.
right,
Oh,
right. So what is probability of x equals to
understood.
1?
Point
Point
2 and point 3.
this
Point 2 and point 3.
point 2 and point 0. This is 0.5, which is probability of y equals to 1. Similarly, if I say probability of y equals to 4, that will give me x equals to 2 and x 2 minus 2, right? So whatever remaining, I don't know. I think this point 1 plus point 2, right? It was point 1 and point 2. Okay, fine. So, so if you can see that this range, when you see how can I get y equals to 0, I'll get with x equals to 0 only, right? When I'll get y equals to 1, when I have these two values,
Yes, sir.
right? So we'll add the probabilities associated with this. So this equals to 0.5, and this becomes 0.2, 3 and this is point 1. Right. 2.
Got it, sir. Thank you.
Right. So like this. Okay. So next up is maybe now we will see some questions from multiple random variables. So here we'll have what joint
Joint
PMF,
PMF.
right? Joint PMF. So if you have two random variables and if there is any intersection between them, then we'll have the joint PMFs there, and based on that we'll find out the values, right? Okay. These things. Okay, and then we'll have marginals also. Maybe I'll take. Okay, we'll see the marginals and conditionals from here, and then you will be able to understand all these equations here. Okay, so let's take out this example. Do you guys have this problem with you? Just
Yes,
let
sir.
me, yeah, just let me know the values. Okay, so, yeah. This y, this x. What are the values taken by
Wait. Okay. So for the y, it is 0, 1, 2, 3.
0, 1, 2, 3, and
For
x
the x part, it is 1, 2, 3.
1, 2, and okay, maybe I try to like this 1, 2, 3, and probabilities are 1 by 6.
One for first row, all 1 by 6.
Huh.
For
Second,
second, it's 0, 0, AB.
hmm,
Third is 0, 0, 1 by 6, 0.
0, 0, 1
1
by
by 6.
6, 0. Okay. Okay. So what this value suggests?
So when our x
Probability of
is 1
x equals
and
1
y
and
is
y is
0,
equals
it
to
will be
0.
1 by
So
6.
yeah. So the
Joint probability.
yeah. So it is a joint probability, and this is actually a kind of intersection, right? So if I say probability of x, so I'll say when I'll get x equals to 1 and y equals to 0, right? So this is nothing but a intersection in terms of the probabilities. When you see like if you have two events, one is let's say event x and event y. So when both events will occur at the same time, right? What is the probability that these two events will occur at the same time, right? This is the same thing which is showing here, right? When x equals to 1 will occur and at the same time y equals to 0 will occur, right? And this is the probability given here. Okay, and what does that mean by this value 0 here? What it suggests? So that
It,
means
wo- it
yeah,
won't be happy.
yeah. So y equals to 0 and x equals to 3, it will not occur, right? This is not possible. Okay. 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 What is marginal of x equal and when of 1? Let's say this is how we define f of, I think, right?
4 by 6, 2 by 3.
So this is like I have to add all the probabilities
In row 1.
in row 1, right? So
Where our x is 1, basically.
right, so let's say I'll write it like this: 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6 is
2 by 3.
uh, 4 by 6, which is
By 3.
2 by 3, right? This is what marginal of x, right? Yeah, maybe I'll write all the values in this column are marginals. Here it is a plus
B.
b,
It's 1
and
by
here
6.
it is m by 6. Okay. What about
1
uh,
by 6. 1 by 6.
For this, it is 1 by
2
6.
by 3.
1 by 6. 1 by
1 by
1
3.
by 3 plus
3
a.
plus A. And 1 by 6 plus B.
Yeah.
okay, okay, this is how we can see like this, right? So you can, what you did here to find marginal of, so f of x of 1, I have added all the values of maybe you can say joint values of y equals to 0, 1, 2, 3 with respect to 1, right? So
One
that's what we
constant
have
and
did,
vary the value of y.
right? And then that we have added across there. So you can see that okay. And what are the probabilities here in joint PMF? First probability is all the values should be positive. right?
Positive.
And second is what? If you do the sum, it should be equal to
1.
1. So sum of what? Sum of all these joint probabilities, right? So okay, okay. And what is another property? So if I add 2 by 3, a plus b and 1 by 6, what should I get?
1.
I should get 1, right? And similarly, if I add 1 by 6 plus 1 by 6, 1 by 3 plus a and 1 by 6 plus b, it should be equal
1.
to 1.
1.
So can you tell me now? I'll get two equations right here. How to solve for a and b? I'll get two equations, right? 2 plus 3, oh sorry, 2 by 3 plus
Plus
a
A
plus
plus B
b
plus 1 by
plus
6.
1 by 6 equals to
1.
1. Similarly, here it's 1 by 6 plus 1 by 6 plus 1 by 3 plus a
Plus A
1 by 6
plus
plus b equals to 1. So these are the two equations. And solve
A plus B equals to 1 minus
1 by 2, right?
5 by 6.
No, it's like okay, it's 4 by 6
5 by
plus
6.
1
No.
6. Yeah,
1 minus
it's
5 by 6.
1 by 6, right?
Hmm.
Okay, so here it's 3 by 6 means 1 by 2 plus 1 by 3, right? So again 5 by 6.
5 by 6.
I'm getting the
So
same equation or what?
I'm doing some mistake, I guess.
B is 1 by 6.
So maybe
B is 1 by 6.
Sorry?
I said B is 1 by 6, like according to me at least.
B is 1 by 6. Okay.
I'm doing something wrong, it seems. I'm getting 6A plus 6B minus 1 is equal to 0.
same.
1, 2, 3, 4, 5, 6.
Same.
Okay, I'll just do the calculations again.
So we should add the joint probabilities and equal to 1.
Yeah, that is one equation, right? So this like 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. So this is like 5 by 6, right? 5 by 6 plus a plus b
A
equals to
plus
1,
B
right?
equals to
Yeah. So this will give me what?
That is also
to
same.
1 by
Same,
6.
right? That is also I'm getting the same. So
B is 1 by 6 and then A is coming to be 0.
sorry.
B is 1 by 6 and A is 0.
So it can be any combination, sir. A and B.
Okay, yeah, I think so. Yeah, right. Not
B is
any
1 by 6.
combination. So I can have. Okay, I think this question is asking us to find which of the following are true, right? So this is also possible, right? 1 by 12 and 1 by 12 is possible.
Yes, sir.
Yeah, this is possible.
Uh,
Anything that adds up to 1 by 6, all the sums that add up to 1
yeah,
by 6 are possible.
yes. 1 by 9 plus 1 by 18.
2 by 18, 3 by 18, 1 by
3 by
6. Yeah,
18, 1
that's
by 6. This is also possible. And okay, I think first is not possible. Second one is 1 by 4 plus 1 by 2 is 3 by
Not
4.
possible.
No, not possible. So these two values. Let's check.
Those
Like
two A plus B is not coming 1, no?
which one? Yeah,
Those selected answers A plus B is 1.
a selected answer.
A plus B is 1. Going back from, I'm working from the result. No, can you please show the answers?
One minute, I'll just,
Yeah, here A plus B should be 1, is it?
no, a plus b should be equal to 1 by 6, right?
A plus B should be 1 by 6. Yeah,
Yeah,
okay, okay.
right. And accordingly, we'll find out because if you see, if I add all the values, I'm getting this equation, right? Uh, okay, I think one equation is enough anyway.
From the selected answers that's coming all right, working backwards.
See, 1 by 12 plus 1 by 12 is 1 by 6,
2
right?
by 12, 1 by 6. Okay, there, 4, 1, 2, 3. No, it's not coming, no? 1 by 4 plus 1 by 2.
It's not coming. Option C and D are correct.
No, option B is not correct, no?
D. B is not
Yeah.
correct. B is not correct.
The option C and D is correct, huh?
Option C and D are correct because that will add up to value 1 by 6. Right? Okay. Uh, okay, I think one more thing is. To show you one more. It is
Sir,
yeah.
how many subjects you are going to ask after 2 years so that we can keep the notes for the future reference? Like this is almost 1 year old knowledge.
Okay, you're saying okay.
Yeah, these were all forgotten.
Yeah, I that's why I'm just doing this recap.
No, no, no. I'm just generally asking, will you be doing the same? Like linear algebra, what we are doing now,
Yeah.
is it going to be asked after another 2 years?
Uh, not
Any,
math. No, no. Mathematically, I don't think so. This now, now, once you go into programming, means like if you start doing programming, mathematics they won't ask mostly, right? Like how to solve the
but in
question.
data science, you will be asking, huh?
Yeah, but yeah, most somewhere it is required the differentiation because if you go to deep learning also, there you need to do some back propagation, and for that you need like calculus. Knowledge of
Okay.
calculus is required. So it's better to carry everything with you, whichever is possible.
Okay.
So yeah, so that's the thing, right?
Sir, do we have questions related to permutation and combination in this Peak 11?
No, 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 no permutation combination. Only
Oh, then it's
probability.
easy, I think.
Yeah, permutation combinations will not be there. Only this
So
kind of
these are basic, that is basic stuff. Right?
yeah basic. But again, that is again you need to do it for continuous. So mostly you will get integration kind of thing, or maybe
Oh,
some
yeah. Okay.
yeah.
Okay. Okay.
Right. So yeah, so we were no sorry. So we'll look into this one first, the conditional probabilities. But I'll just show you first the simple one. So I'll
What's the
use
formula for conditional probability? There was this formula, right?
yeah, yeah, I'll tell you.
Okay. Okay.
It's
It's
1
fine.
by 12, and let's say this is the now we'll write down all the marginals again. So I've selected these two values. Okay. For A, I'm selecting 1 by 12 and B as 1 by 12, and this is my PMF. Okay, right. Can you tell me what are the values now? The 4 by 6 is 2 by 3, 1 by 12 is 1 by 6, and I think this is 1 by 6, right? 1 by 6. Just check the calculation, okay?
Yes, sir. Correct.
And 4, 4, 5.
4 by 12
1 by
This
12, right? Which
is
is 1 by 3.
and 3 by 12.
It's 3 by 2, which is 1 by 4, right? Okay.
Hmm.
Uh, okay. So suppose if I wanted to find the conditional probability, right? I'll just write down like this. That's why, let's say, mm, what is general formula for conditional probability? If I say for probability of A
By
given B,
marginal.
A given B is what?
Joined by marginal.
Yeah.
P
So
of A intersection B divided by P of B.
probability of A, right? B,
B. B.
right? So if I do it for this one, so sorry, f of x given y, It should be what?
P of
Xy.
x y. Sorry, f of x y divided by f of y.
F of y.
Y.
And what is f of y? This is marginal.
Marginal of y.
Marginal. And this is joint density, right? So this is general formula for, and this is what? Conditional. Okay. So if you see, I can write my joint PDF as what? Conditional into, sorry,
Margin.
into marginal, right? Okay. So let's solve for this. How to find this value or condition maybe. Or shall I take one simple example first? Okay, maybe I'll write down like this. Maybe 1 by 2. What does this mean?
F x y f x equals to 1.
Yeah, so I'll write down
Y
like this:
equals to 2.
x given y as
No, no.
of x equals to 1, given that
Y
y
is
equals to 2,
equal
which
to
will
divided
I'll write as joint of x equals to 1 and y
y is
equals
equals
to 2,
to 2 divided by y. F of fy of 2.
right? Divided by fy of 2.
2.
Now, can you tell me the values from this? Okay, maybe I'll show you the table first.
0. No,
I
no,
chosen the wrong one. Huh?
no,
X
correct.
equals to, yeah, x equals to 1 and y
1 by
equals to 2.
6 divided by
This is the value.
1 by 3.
Yeah, this 1 by 6 divided by
1 by
fy of 2 is where?
1 by 3.
Fy of 2.
In
This,
that column. In the same column. Hmm.
right?
1 by 2.
1 by 3, right? So
Hmm.
yeah,
Yes, sir. Yes.
and if I do the
1 by
calculation,
2.
this will become 1 by 2.
1
This is
by
what?
2.
By giving, 2. Right, okay. So suppose if I wanted to find it out like this, of x given y of uh, x, what does that mean? Okay, what is, how can I find it out? Okay, what is this means is fxy x 2 and
You have to do it for the whole range of x.
x, right? You have to do it for whole range of x. So I'll find it out for
X equals
when x equals to 1,
to
then I'll find, given that 2, then x equals to 2 given that 2,
2,
and x equals to 3 given
3,
that 2.
2.
Okay, right?
Hmm.
Okay,
And then sum.
and then some. Okay, that is another case. So okay, so this you understand, right? And if I wanted to do it for like in general for fx of, so like this, so how to find it? This y and y. So that means I have to draw a, or I should find out the conditional probability table, right? This is the question which is asked here. Which of the following option represents fx given y of x, like y? How to find these values? Okay, shall we try this question first? We'll
Yes,
see
sir.
if we are able to find it out. Okay. So if you can tell me the values, it will be good.
Wait, so which this week only, no? Okay. Yeah. Y is 1, 2, 3.
Y is 1, 2,
2,
3.
3. X is also 1, 2, 3.
X is 1, 2, 3.
First row 0, 0.10,
0, 0.10,
10, 0.08,
0.08,
0.20,
mm,
0.10,
mm,
0,
0,
0.02,
0.02,
0.30,
0.30,
0.20.
0.20, right? Okay, so this is my PMF table, and what we have asked is we have to find fx given y. So that means generally the conditional distribution, right? This what we have asked to calculate. So for that, what I have to do, which are the things generally I know okay, all these values are joint PMF values, right? I need to find marginals, right? So f of x is I think f of x is not needed in this case, but let's find it out. What is the value? It's 0.18, 0.30. This is
3 to
0.5,
be. Yeah, 5 to.
right? 3 to 50 and right,
So what have they asked in the question, like
this one,
based on this?
this one.
Okay.
Okay, this is the question. So okay, to find this out, like what I have to do is, because fx y, I need to find all the distribution, right? X given y, that means I need to find fx y of x y y, right? Y of y. For that I need to okay, I need to find marginal of y. So what are the marginals of y?
0.22,
To
0.50,
0.50.
0.28.
Okay. Uh, uh, and if you see how this distribution is, it's between x and y of these values, right? So 1 2 3 and 1 2 3. So which value will find it out first? To find out all this distribution, maybe I'll find out, let's say, fx given y of maybe
1 1. Sir, whichever is varying, we will find that.
huh. So how to find it?
fxy of
Is
1
zero.
and fy of 1.
It will be
fx
0.
0 only.
1 1 is 0, right?
Hmm.
Okay.
Yes, sir.
Y of 1 2 maybe
0.10 by 0.50.
0.10 divided by
0.50.
uh, f of fy of 2, this one, right?
Okay, yes, 0.50. But
Any issues here?
no, sir,
0.2.
no, sir, no, sir. But
Okay, if anyone has having doubt, see fxy given 1 comma 2 is what? This is nothing but fx equals to, sorry, joint density of when x equals to 1 and y equals to 2 divided by fy of 2. So fy of 2 is 0.50, right?
yes, sir.
X equals to 1 and y equals to 2 is this value. Okay. uh, and I think this is how much?
0.20.
0.20.
0.2.
So the D option will be correct as soon as we
Yeah,
derive this.
yeah, and now you can see, right? When next value is 1 and 3, right? 1 and 3 will be 0.08 divided by
0.28.
0.28. Again 2 1 is 0.20 divided by 0.22. 22 is this one divided by this, right? Now you understand. So you can calculate the values and you will get, I don't know which option is correct. 0.20, I think this is the only case, right? 1 and 2, and you can check this. Okay.
Hmm.
Or let's find it out for this, maybe f x given y of 2 comma 1. So this is nothing but fxy of 2 comma 1 divided by fy of 1, right? So f of f of x of if sorry, fxy of 2 comma 1 is how much? Yes,
0.20.
0.20 divided by
Yeah,
fy of 1 is
0.20.
0.22,
Sorry, huh, 2 2.
right? So this is, you just calculate. So I think, yeah, right, because 20, it's almost equals to 1. You can see from the options in the table, it's, I think it is 0.9. Understand?
Yes, sir.
Okay, so let's suppose if I wanted to find this distribution, how will you find out this distribution? Fx, sorry, fy given x of y given x.
Uh, Nothing will change. Just the bottom part will be changed. Some probabilities will change. That's
So, so let's say if I wanted to find for x, sorry, y given x of 0, not 0, 2 comma 3, what will be the value? Which value should I take?
Okay, wait. 2, y is 2 and our x is 3. So
Hmm.
0.30,
Y is 2. Sorry, y is 2 and x
0.30
is 3. So this value 0.30
or 0.52.
divided by 0.5.
So
Right?
how you're taking?
See, okay, fy of x, so that means fy given x of x equals to 2, sorry, y equals to 2 right now, y equals to 2 and x equals to 3. So this is fxy, joint density of x equals to 2, sorry, sorry, so y equals to 2 and x equals to 3 divided by fx of 3, right? This is the formula, right?
Mm-hmm.
Okay, so that means y equals to 2 and x equals to 3 is which value?
Y is equals to what?
Y equals to 2 and x equals to
0.3.
0.3, and fx of 3 is denominator, right? Denominator is
0.52.
0,
So
denominator is
I actually didn't understand that notation.
okay, fine. Maybe I'll write it here.
Fy given x of y given x.
Fy given
Given
x
x of
of
given x.
uh, this is
That's
2,
what you written, right?
maybe I can say 3 comma 2. So this is what fy given x is
First one will be y, second one will be x.
okay.
No, no,
I,
sir.
I will not.
That 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 is I know.
Actually, she is confusing in the formula, it
Hmm.
seems.
1 minute, I'll just write down the values, then you'll get understand. Right? So this is the case, right? General case, how to represent the conditional probability in this case? It is fxy
Fxy divided
of,
by fx.
yeah, divided by fx, right?
Hmm.
Fx. But now here x is equals to how much,
3,
and y equals to
2,
2, and in the denominator
three,
fx of
3.
fx of 3. So x equals to 3 and y equals to 2. The joint PMF joint probabilities where
Mm-hmm.
this value,
0.30.
and divided by fx of 3 is what, marginal of 3. So
Correct.
marginal of 3 is 0 point,
0.52.
so this value is nothing but 0.30 divided by 0.52, whatever value it is coming. So if you wanted to find the distribution of x given y, you will divide by using the
By
marginal.
of
So
y.
it will be this value divided by this, right? This value divided by this, like this, right? In the column.
Uh-huh.
When you are finding fy given x, then you will be dividing these values by this, right? Understand?
Understood, sir.
Okay, so this is everything about uh, multiple. Okay, I think one more point here is what is the uh, expectation of multiple random variables. Maybe okay, this is now messy. Can you just tell me one more times?
Yeah,
Uh,
sure, sure.
yeah.
Okay. Same values.
Yes.
Y is 1, 2, 3. X is also 1, 2, 3.
Yeah. 1, 2, 3. Yeah.
0, 0.10,
Mm,
0.08,
mm,
0.20,
mm,
0.10,
mm,
0,
mm,
0.02,
mm.
0.30,
Mm.
0.20.
20, right?
Yeah.
Okay. Right. Now we understood about what are marginals, what are
What are
joint
conditions?
probabilities and conditional probabilities, right? Okay. So now I wanted to find the expectation of uh, this joint PMF. Like how to find that? Is it possible or not? First of all, that is a question. Okay. First of all, I need to see whether it is there in your syllabus. Okay. Yeah, it is there. Okay. Okay, and consider this as independent random variable. So now x and y are independent.
So what does that mean?
Okay, what does that mean? Huh? Right.
Hmm.
Sir, is it
So
given in the question, sir?
yeah, it is given, but okay. First of all, how to check for the independence? That is important thing. So fxy, if fxy is equal to f of x into f of y, if this is satisfied, then uh, x and y are independent, right? And if fxy is not equal to f of x into f of y, so what is this? The multiplication of the marginals, if that is equal to the joint pmf or joint probability, then they are independent, right? And if not, then they are dependent.
Maybe you can solve one like part.
Yeah. In this
F of
only
X and
we'll check for this question itself, right? So this probability itself will say. So first of all, I'll write down all marginals. So this is 0.18, 0.30, and this
0.52,
52. Fy's are 0.22,
0.50,
50, and
0.28.
0.28. Okay. What I said is, let's say for this case, okay, fxy of x equals to 1 and y equals to 1.
Okay.
What is the what is the value? Is 0, right?
Yes, sir.
Right, this value, right?
Hmm.
This value. Now, uh, what is f of x of 0?
F of x of 0
No, sir,
doesn't exist.
not 0. No, sorry. 1. Sorry. F of x of 1,
0.18,
0.18. And fy of 1,
0.22.
fy of 1 is 0.22. So, what is the product here?
Not equal to 0.
non
Not
zero.
equal
Yeah,
to 0.
0.8 into 0.22 is some value, and which is not equal to 0, right?
Not equal to 0.
That means these two are
Dependent.
dependent.
So we have to check this for each and every part,
Each,
or
yeah, each value. So if you check for, you have to check for this also. So
like
this
for
is
For,
example,
for
in case it just satisfies 8
one,
independent and one is dependent, so the whole
all is
system will be dependent.
dependent. Yeah, that is
Okay.
certain, right? Now you
to
understand?
prove it is independent, we have to check all values.
Yeah, if you find any value which will satisfy this, which is, that means joint is not equal to the margin product of the marginals, then they are definitely dependent, right?
Yeah.
And for independence, you have to check for everything. So if you find any one like this, uh, it's concluded that there is independent, sorry, dependent, or maybe not independent. And for other value, and for independence, you have to check for every each and every value. Okay. So in this case, it is dependent. Okay. Okay. Let's maybe, okay. I think you know the properties of expectation, right? So what are the properties of expected value of x plus y is what?
U of
Expected
x
value
plus
of X.
y.
Right? Okay. And I'm talking about, currently I'm talking about if x and y are independent. Okay. Anyway, this rule is applicable for dependent also, but generally we deal with independent, uh, variables, where random variables, where is see the rules here.
So
So
can
if
you
we,
tell for both, right? Like for dependent and independent both, right?
uh, actually, see, in this case, this is valid for dependent and independent. That does
Okay.
not change. Okay. Only change is happening in terms of variance, because in terms of when you do for it variance, right, you will not be able to in the multiplication only. That is also for multiplication. In terms of expectation, it does not change anything, right? And so expectation of x into y is what?
EXY.
Expectation of x into,
Y.
this, correct or no?
For
I don't know.
independent, it is correct.
For independent case, right? So expectation of x plus y is expectation of x plus expectation of y. Expectation of x into y is expectation of x into expectation of y. Similarly, for variance of x plus y is variance of x plus variance of y, and that is true only for independent case. Okay, when x and y are independent. Then variance of x into y is what?
Variance of x into variance of y.
No. Okay. And yeah, again, if this, so let's, maybe I'll take some example and really. I think this things you know. I just wanted to see any other example which is dependent case. Uh, no, no, there is no possible. Fine. Look, in upcoming examples, we'll check this one. Okay. If in case of independent and dependent, but this is the thing that, okay. Which of the following statements are correct? Now we have seen, so that if you can tell me. So
Mm,
Rx is what? Rx is the range of x and Ry is range of y.
x.
Which question, sir?
Question number seven. Seventh. Tell me first for seven.
Correct. मतलब, like yeah.
First is
Second one.
first is correct or not?
Seems like the first one is correct.
Correct, sir.
First is correct. What about second?
Second. Second is correct actually. If it is independent, then it will be equal.
If it is independent, then it will be
But first one is also correct, na?
first one is correct. Yeah. Okay. What about third?
Independent and dependent.
Third and fourth are incorrect, obviously.
Third and fourth are incorrect because they are. So if you see, so first
But we have to mark only one.
Sir, second one is incorrect because for being independent, it should satisfy for all x and y.
But that's what it means, right? It's satisfying for all.
Yeah, like we are
But
just
uh,
giving x and y.
but
Like
in the option, it is given
no,
for
for
some.
some x. Yeah, for
Huh.
some x.
That's why it is incorrect.
Oh, okay.
Yeah,
Okay.
and first option is for some x. Yeah, right, correct,
okay.
right.
Good. Yeah.
So what is correct?
First
Everywhere it
Option
is.
one.
One.
One for some x only it is there.
So like even if it's for only one x, it will be dependent.
Even it is. That's not the way it is, no?
No, that's the way it is.
Okay, what
Whole matrix, if it is only one, then the whole thing is
dependent?
Dependent. Yeah.
Yes.
But
independent.
for independent, it won't work this way.
For
For
independent,
independent, it will be
everything
dependent.
got to be
Yeah.
equal, no?
Yes. So for independent, for x and y to be independent, the uh, this statement, right? The second statement should be true for all x,
Yes.
right? Then
Hmm.
only they are independent. Okay. And for dependency, if you find any one of the case which is not satisfying that equation, then that directly will tell you that they are dependent. Okay. Fine. Okay. I think multiple random variables we have. Okay, this we have seen about discrete. We'll see about, you know, mm, continuous. But do you guys are you guys familiar with Bernoulli binomial Poisson geometry, or do you
Binomial
need
is
me
like
to?
low one. Like I
Okay.
don't. I
Okay, you
remember that.
guys don't. Okay, fine. So maybe I'll briefly explain what is Bernoulli binomial Poisson and geometry. Okay.
So we'll be given with the formulas of all these, na? Like Bernoulli binomial and stuff.
Bernoulli binomial. Okay, I'm not sure in
CDF
MLF
and
we
CDF.
use.
Because in stats 2 it was given.
Yeah, stats. So we used to give it.
Just look at the stats to paper, bro. The exam.
Yeah, we can do that.
Yeah.
But
Okay. Okay, fine. All the things are there, right?
Stats 2 is a nightmare.
Okay, but
Yeah,
you
stat.
all of you have passed it.
I just barely passed that subject.
And
I don't know how I passed it.
Like I was just mugging up all the questions from last 4 weeks, and that's how I just passed it. I didn't understood anything, but I just mugged them all.
no, why I don't think it's like that difficult, right?
Max was still difficult, sir.
Like it was not difficult, but some parts were not like in my understanding were not explained that well. Some parts.
Okay,
The only difference is maths 2 you understood something and passed. In stats
Yeah,
2 understood
Matthew
nothing, you passed.
okay.
and but the Matthew quiz in my time was just out of syllabus, sort of.
But currently you guys are able to understand whatever I'm trying
Yeah,
to say.
currently we are
So,
able to understand because we have passed that thing.
so that
While
means you
studying
understand
that
it only.
thing, the thing is just out of our reach.
Okay,
If you reappear, will you pass?
Yes,
okay,
yes, obviously.
okay. Then that is enough, right?
Yeah.
Fine. So what is Bernoulli? It's like very simple thing. What is Bernoulli trial? So Bernoulli trial is, or maybe the experiment is, if you toss a coin, you will get two outcomes. So any case, if you get two outcomes, right, in one experiment, that is your Bernoulli trial. For example, it is uh, it will rain on the particular day or not, right? So it's raining on a day or not. So these are the two outcomes only. So here you can say it's a Bernoulli trial. Another example is, let's say if I roll a fair die, okay. What are the outcomes? And I say my success. So I define my success x as getting a 6. Okay. So is it a Bernoulli random variable x?
Yes.
Yes,
Yes.
right. So I'll have two outcomes of it, right? Which is I'll get either 6 or
Z.
no 6.
No
No 6
6.
means 1, 2, 3, 4, and 5, right? And since it's a fair die, that means what does that mean? Fair die. So the sample space will be what,
Probability
Equal
of every
probability.
outcome is 1/6.
right? And
Sample
each
space will. Yeah.
each will have the probability that 1/6, right? Maybe I'll write it like this. Uh, each of them will have probability 1/6. Okay. So the Bernoulli random variable will be defined as like this. So uh, suppose I say 6 as a success. So I'm assigning value 1 to x. This is for getting a 6, and this is for not getting a 6, right? What are the probabilities associated with this?
5/6 and 1/6.
5/6 and 1/6, right? This is your Bernoulli random variable or a Bernoulli trial. Okay. Uh, right. So what is the difference between Bernoulli and binomial?
Yeah, yes.
Okay.
Binomial is addition of Bernoulli.
Yeah. So you are saying that how many success you're getting in fixed number of trials, right? So binomial is nothing but uh, number of successes in uh, fixed trials, and it may be n. So and okay, and each of the trial will have how many outcomes? Two, right? That's why it's binomial.
Only two.
Two outcomes. So for example, if I toss a coin once, that is my Bernoulli, right? But in case of binomial, I will toss a coin 10 times. So 10 is what? N,
Fixed.
right? This is the fixed number of trials, right? In 10 tosses, how many heads I am getting? So if so, let's say x will be number of heads in 10 trials, and this is what, a binomial random variable. And binomial means what? Each of the trial I'll get two outcomes only, right? That's why it is called as binomial distribution, right? Multinomial
But
means
only also the outcomes will be two only, no?
yes, binomial also the outcomes will be two, but it is here only one trial is there, right? Only
Okay, in
one trial,
Bernoulli,
and
only one trial happens.
yes, and binomial is the
Fixed number of
repeated. Yeah. So binomial is nothing but you can say repeated Bernoulli trials. right? Repeated Bernoulli trials, and hence it is called as IID. What is IID? Independent.
Independent.
Identical and
Identically independent.
So this is independent and identically distributed, right? What does that mean, independent? So if I toss coin 10 times, so first toss, the result of the first toss does not depend on, or maybe I'll say result of the second toss does not depend on the result of the first toss. Result of the third toss does not depend on result of the either the first toss or second toss, right? That is what independent is. And what is identically distributed? Each time the distribution is same.
The
What is
probability
this?
is same.
Yeah, so distribution is same means I'm each of the trial is having, it's Bernoulli, right? So Bernoulli means the probabilities associated with that distribution is same, which is in this case, let's say it's 5 by 6 and 1 by 6. So each time if I roll a die, so if I roll a die for 10 times, every time getting a 6 is having probability 1 by 6, and getting or not getting a 6, the probability is 5 by 6 each of the trial. So that is what
IID.
binomial distribution, right? And okay, or that is what IID. And what is X here in case of binomial distribution? It is number of successes in fixed number of trials, right? So let's take some
So
small
our
example.
Bernoulli is IID, but our binomial is not IID.
Bernoulli is not IID. There is no IID, right? In binomial we have uh, IID IID Bernoulli trials, I can say, right?
Okay,
Right? So
but not
10
IID.
IID, 10 IID Bernoulli trials, right? Independent and identically distributed Bernoulli trials. I'm doing it for 10 times. Okay,
Got it.
right? Okay. So I'll ask you one question, maybe the simple one. Let's say, okay, maybe this is Bernoulli. The same thing I'm doing is roll a die, and I'm defining a success as getting a 6, which is having probability 5 by 6. Okay, but okay, and if I this roll this above die 5 times, and asked you the question, maybe what is probability that, and then suppose this I'm denoting by y. What is probability that y equals to 2? What does that mean?
Success. We're getting success 2 times.
What is success here?
Getting a one.
Getting
One.
one is what? One is getting a 6,
You're getting a six. Sorry.
right? So what is probability that y equals to 2? Y is here. Y is binomial random variable. I'm saying that I need two six two success in 5
time.
5 trials, right? And trials means rolling a die 5 times, right? So how to calculate the probability of y equals to 2? First of all, in 5 trials I will choose any 2 trials, right? Because in 5 trials I can get these 2 successes, or that means 2 sixes in any of the trial. So I'll choose 5C2, right? What is probability of getting a 6?
1 by
1 by
6.
6.
1 by 6.
And I need it how many times?
2 times.
2 times. And that leaves me what with 5 by 6 to the power
3.
5 minus 2, which is 3, right? And this is how we calculate the probability. So uh, let's say if x is a binomial random variable, then in that case probability that x equals to, let's say, r is what? Number of successes.
Number of successes.
Okay, n is number of fixed trials, then in that case it should be NCR. What is this? Probability of success, P to the power R, and this is
1 minus p to the power n
1
minus
minus
r.
P to the power n minus R.
F and minus R. Super.
So you understand, right? So this is I'm choosing, like, because there are 5 trials, I chose 2 trials out of the 5 trials, right? Because I wanted only 2 successes, so I can choose any trial. So maybe I'll get 1 success in the first trial, or second, or like consecutive first 2 trials, maybe last 2 trials, or in between anywhere, like, so there this is the combination. So in 5 trials I'm getting 2 successes, so it is NCR. Then if I am getting for R times, then it is P to the power R, right? Probability of success, that many times into 1 minus P to the power n minus R. This is understandable, right?
Yes, sir.
Okay. Now the another case is what? Geometric.
Geometric.
So again, what is geometric?
Yeah, this
Getting
I
You have
just
to perform the
Getting first failure.
first success or first failure? Yeah, actually this is,
First failure.
yeah. First failure is also fine, or first success is also fine. Not first failure, I'll say.
first success, no?
Yeah, first success. There are 2 types actually to define this. Uh, yeah, 1 minute. Just give me a minute.
Geometric and Poisson are same.
No, 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 no. Okay, sorry. Okay, I think we have to finish like a lot of things now. Okay, getting a first success, right? So, for example, if I toss a coin, okay, now I'm giving some another example, right? Maybe this is easier one, that's why I'm taking it. Or okay, anyway, we'll use that same example. So, suppose I have rolled this die 5 times, or not 5 times. I'm saying that I need, or maybe I'll get, what is the probability that I'll get a success in the fifth row, or fifth, or maybe on the fourth roll. What will happen? So in the
3 will be failure
that
and then
means,
4 will be success.
yeah, that means I won't get the success in the first, or maybe I'll get
three
in the
throws.
first trial I don't get the 6, second trial I don't get the 6, third I won't get the
So
6,
no,
but fourth
four,
I'll get the
6,
success, or that is here it's 6. So what is probability here? Not getting the 6 in the first trial,
5 by 6,
5 by 6, right?
5 by 6, 5 by 6, 5 by 6,
Into 5 by 6 into 5 by 6, and here it
one
is
by
1 by
six,
6. So this is what? 1 minus P into
one
1
minus
minus P into 1
into
minus P, and this
into
is P. So if I combine all of this, it will become 1 minus P to the power 3 into P.
P. Yeah.
So if I want, let's say I define geometric as X, random variable, that getting a first success or getting a first 6. So let's say, and that is 2 in the which fourth, okay, in
Fourth place, yes. Fourth
Arth,
row.
maybe I'll say Arth, uh, what do you say?
Earth throw or something like that.
Yeah, a trial or something, yeah, something like that. So this is it, right? So suppose if I wanted to check probability of, or if I wanted to generalize it for X equals to R, it will be equals
One
to what?
minus P
P to the power R
minus 1.
to P. Sorry, R minus 1, yeah,
That's it.
right? Do you understand now what is geometric? Simple, right? So all of, so Bernoulli binomial and geometric are, I can say, very
Pretty easy.
related to each other,
Yeah.
because Bernoulli will lead to binomial, and again Bernoulli, same thing is there. So this is again, it's Bernoulli trial, right? right? And I can say that I will, maybe I can do in the same way for the geometric cases. So what about Poisson? So Poisson is okay. There are a lot of assumptions associated with Poisson again, but I'll just tell you. First of all, write down the formula here. Right? Poisson random variable probability that x equals to x. What is it?
E to power minus lambda, lambda
R.
to power x. Okay, R.
So
Upon x factor.
Poisson variable is a variable that follows some kind of distribution, right? As far as I remember.
It is following Poisson random variable only, right? Or Poisson distribution. So actually, it is what I can say.
What is lambda here?
Lambda is average. Uh, so okay, I will define maybe.
Average of what?
Okay, so I'll tell you. So maybe I'll give you an example. In that case, I'll tell you. Okay, I'm not telling you the proper definition here, but what I'm saying is, in a given interval of time, what is so let's say if you are there in a telephone booth, and let's say I know that the number of phones coming in 1 hour, it follows a Poisson distribution with average number of calls is 2. Okay, so in that case lambda is equals to 2, right? So that means the average number of calls coming in an interval 1 hour of interval, it's 2 if it is follows the Poisson distribution. uh, yeah, events are happening in the fixed interval of time, right? So if I wanted to find, so if I know that the average number of calls coming during 1 hour of interval of time, and if I wanted to find the probability that what is the okay what is the probability that in the next 1 hour I will receive one call only. So we'll use this definition or this formula to calculate the probability.
When I Google that one, it gives the mean number of events within a given interval of time, lambda,
Correct. Right. Mean number of events in the
given interval.
given interval of time. Right. That is true. Okay.
Sir, R is get the probability of getting X equal to R in a
R is means like
one interval.
okay. Okay. I give you one example right now.
So what is the success there? It is x is equal to r is a success.
It's like how many calls we'll get in a.
Yeah, success
Right.
I won't say here, but it's kind of we are finding the probability for happening that event. Right. It's not here the
Oh, okay.
success and failure thing, because success and failure is associated with Bernoulli trial. What we are finding is what is the probability of occurrence of that event, right? So suppose in prior I know that okay, the number of phone calls. Okay, number of phone calls follows, let's say, Poisson distribution. Okay, with lambda equals to 2. What does that mean? That means 2 number of calls per hour. Okay, I wanted to find the probability that x equals to 1. So r here is what? So I wanted to find the probability that we'll get one phone call in next hour. Okay, how to find this? We just have to plug in the formula. That's it is e to the power what is it minus 2 lambda to the power lambda is what here. So event here is receiving one call in the next hour. Okay, receiving so you can have like 3 calls. You can find the probabilities for any number of calls, right? And what is the range of Poisson random variable here? It is 0, 1, 2,
Infinity.
infinity, right? So that is the range. So you can find the probabilities for occurring of 0, occurrence of one phone call. So that means you can find the probability, right? So if it is out of the bound, then you will get the probabilities for those events. So for example, I may get zero probabilities after maybe after 10, or if I want to find the probabilities x equals to 10, right? In that case is I will get the zero probabilities associated with, or nearly very zero probabilities, because you see the average number of calls I'm receiving is 2, right, in that one interval of time. So if I, there is, it's not likely to happen that I will receive uh, like large number of calls, right, like maybe 15, 20, 25, right? If I have the average number of calls coming is let's say lambda equals to 15, in that case uh, I can think of like having the good probability of occurrence of 10 number of calls in the next hours, right? You're understanding my point? So this lambda is actually telling you that how the distribution will be uh, looking like, right? Or maybe because lambda is, I think it's a mean in this case, and you can think about it like the number of calls we are receiving, it depends on the lambda, or what is the events happening again in the next interval of time, it depends on the lambda, right? Okay, so I think maybe I'll just, shall we move into the continuous pdf, continuous random variable and conditioning,
Yes, sir.
right? So we'll finish it off, at least we'll finish all these independent things, so you understand it uh, uh, for the case of discrete random variable, we'll just do it for continuous random variables.
I was going through a thread, and there it was written that we need to have good knowledge of bias and one more thing, risk, I guess.
Okay, by for week 11,
Yeah, I guess. Not sure.
I think it's in week 12,
week 12,
the
yeah, week
testing and
12,
all.
yeah, week 12, because we are having Chebyshev Markov inequalities, and yeah, hypothesis testing also, I think it's covered there. So here it's not needed. So, okay, anything is any important thing here?
Now maybe we can solve all these questions.
These are simple only, right? Okay, you guys try this one. Maybe I'll tell you the answers.
First one is insufficient data.
It's never insufficient data.
Oh, got it.
7.
Like just basic addition.
That's true.
7.
So, sir, could you tell us all the properties of variance and yeah, that are in the letter and expectations?
I guess sir is exactly.
Okay, so did you get the answer for this? I think I have already discussed this one.
No, it is 7.
7. Okay, yeah, I think it's like a simple one. What about this?
49
343.
49 into 7.
49 to 7, right?
343.
Yeah, variance of constant random variable will be,
0.
yeah, right, this one. But I think, okay, I think I'm not sure like they have written it true or not. Yeah, that is false. Why? Because this is true only for independent random variable, right? This is not mentioned here. Okay, maybe I need one example. Actually, I wanted to solve some estimate targets.
So what if variance of x, y is if we multiply?
What is variance of?
xy.
Variance of x into variance of y, independent case, in the independent case only. Otherwise, that is not true.
Even addition is true for independent.
Yes, yes. Okay, okay. Maybe I'll have this question here. I'm not having that independent case, but let's go through continuous case of random variable first. So I'll go it like somewhat faster, okay? Uh, because it's very similar to what we have seen earlier. We'll see what are the uh, what is continuous random variable, their PDF, because here we describe it as a PDF, right? Probability density function, and then we'll see what are the conditional probabilities and everything, right? So this is a random variable we are given. F of x is equals to 3x square within the range 0 to 1, and it is 0 otherwise. We have to find probability that x is less than or equal to 3 given that x equals to 3, 1 by 3. So what is PDF here? Given here 3x square between 0 to 1 and 0 otherwise. Do you want to visualize this one, like how it will be looking like? So let's draw it maybe. This, okay, right? Same as that of this. Okay, how do you think this will look like?
Parabola.
Parabola, but I don't think it will be able to see the parabola exactly here, right?
Yes.
Because
It
this
is
is
only
in
from 0
between
to 1.
0 to 1 only, right? So if I
Ah,
wanted to see, so yeah, it will cut here somewhere, right? Here, and yeah, I think this will look like this. So yeah, okay, my range is not proper here. Small, it look like something like this, right? Okay,
So this means that the probability of getting a number close to 1 is I.
probability of getting a number close
Close to
to
1 is I.
I. I is what?
The probability of getting a number close to 1 is more.
High. Okay, okay, high. We are saying okay, fine.
So can we say like that?
Mm,
Because the graph is higher when it is getting close to 1.
I'm not sure about it. It is
I
generally
think
okay.
for continuous variable, it's the
Yeah,
range, right? It's not a What he's saying is for discrete variable.
yeah. But okay, but generally, how to calculate the probabilities? Actually, this is a PDF, right? This is a PDF of
Area under the graph, I think,
yeah, and
using
generally we
integration.
yes, right. So that is what is for that we define CDF, right? Cumulative density function, right? Right. So generally, how, and this is denoted by capital F of x, if you remember it. Now, what is f of x? It is integration, right? This is correct. Actually,
Yes.
we didn't find the CDF for PMF, but this is that was there only. It's what, it's a summation of all the probabilities. But here, if you, and this is nothing but what, area under the curve, right? Right. Fine. This okay. Everyone is fine here. And generally, we define for continuous random variable the probabilities in the intervals, right? So that means I'll find out f of 2 minus, or maybe I'll say f of 1 minus f of 0.5. Okay. What does that mean?
0 to 1, and first you
So I'll
integrate
integrate between 0 to 1,
1.
right? And what I have to integrate here? 3x square dx minus integration of
0 to 0.5.
dx, right? Okay, and that's how you'll find the probabilities here. Okay, but if you see, okay, what is general PDF now for the above PMF, not PDF.
Minus infinity to x, you integrate. Uh,
Let's integrate it here. Minus infinity to
X.
x, f of x dx, right? So in this case, it will be. Is it okay to
So,
start with 0 to
yeah,
x,
yeah.
0 to x, 3x square into
Dx.
dx, right? So this is 3x cubed by 3 from 0 to x is
X cube.
right, and this is for 0 to 1, I can say, right? Okay. One more property here is what? See,
A-
property of
area must be equal to 1.
area must be equal to 1. Another thing is the
Below
probability values will be always between
0 and
0
1.
to 1. For CDF, it will never cross 1, right? So that will always be between 0 and 1. Okay,
So beyond 1 it is 1, and below 0 it is 0.
right, right. So, for okay with this, if you find out the probability, what is it? 3x square, so it is 1, right? 1 minus
0.5 cube.
0.52. So if someone can calculate it, 25.225. So 1 minus 0.225 is how much?
8.75 maybe.
0.875, right?
Yeah, 0.875.
Okay. And we'll see now whether it is correct or not. So we have, this is generalized CDF, right? For the above PDF. So f of 1 is how much from here? 1. F of 0.5 is how much? It's 0.5 cube, right? It's 0.225. And now you can check. This will, you will get this answer. So either you will find generalized formula, then put all the values which is asked here, and then you will get the answer, right? And generally you will find the probabilities like this: f of b, so f of b minus f of a, for the interval of between a and b. Fine, is okay.
Yes, sir.
Okay, so we'll define one more thing here, is expectation of a continuous random variable. Okay, for single random variable, I'm going to define here. So expectation of x is how, what is it? Sorry,
That is x into PDF.
integration of minus infinity to infinity x
X
into,
PDF.
yeah. Okay,
The
what about,
PMF.
no, PDF, this PDF, right? This continuous random variable, right? So for continuous random variable, we'll always have PDF, which is probability density function. PMF will be defined for discrete random variables, right? Okay.
So, sir, what if the PDF like has multiple? I mean,
Multi.
Multiple.
like we for in the previous question we had that it was PDF was 3x square between 0 and 1, right? So
Hmm.
what if there were two or three values, like with 3x square there was 2x square and 1x square, it was distributed like that, then how would we calculate the expectation?
So you integrate within the range. You
And then add them.
Huh.
Okay.
You, I think you are saying that. Oh, okay. First of all, I don't
Oh,
understand.
okay, okay. I got the integration property that, yeah.
No, no, but still, is it? Do you get it properly, right? Or I
I
don't
got it.
understand the
So,
question itself. Like,
like there in for integration, we have this property, right? If integration from A to C is equal to integration from A to B plus integration from B to C, right?
huh? That is there. Yeah.
Okay, okay,
In
okay.
in the
Got it.
different terms, you can actually add. Okay. Fine, fine. Expectation of a continuous random variable. What else is there?
Are there independent and dependent
No,
continuous random variables?
there are, but dependency and independency will come when only when we'll define for multiple random variables, right? So currently we are dealing with only single random variable.
Do we have multiple random
Yes,
variables in
yes,
our syllabus?
yes, yes, yes.
Mhm.
Okay, okay. Can you tell me the answer for this question first? Second one.
Sir, are we finished with recap? Sorry to interrupt.
Recap is done.
Okay,
We are in week 11 currently, and I
okay,
think we'll finish it in like maybe 10-15 minutes. We'll finish out week 11 also.
okay.
So it's actually week 11 is nothing but whatever you have studied in stats 2, right? Stats 1 and stats 2. Generally it's like that only.
Yeah, but I think it's not that difficult as stats to maybe. I don't know. I'm not
Yeah,
sure.
yeah, not much. Until week 11 it's not much. Week 12, yeah, it's like some more advanced concepts are. Okay, so tell me about question number 2.
For the n term, all are equal weightage, no?
Weightage, maybe I'll talk about it later, okay? Maybe after some time.
I
So
think first option is correct for second question.
First option is correct, you're saying?
Mm.
Okay, fine. This is
First
nothing
and
but what?
last.
This is the definition of this one, CDF only, right?
Yeah, yeah.
Provided x is less than a. Okay, I didn't define it here. Maybe actually, what is CDF?
It's like intuitive.
Hmm. This so that x is less than a. Okay. What is second?
Value from.
This is correct. Option B
so B is the
Yeah,
statement
both are right.
reasoning is wrong.
will be same since probability is equal to area. Reasoning is correct, no?
The reasoning is correct, but I think
It is correct. Option B.
Option B is correct, right? Because uh,
we don't consider boundaries in continuous variables. No.
if you like if you consider them or not, it doesn't matter actually, there, right?
Yeah.
So,
Mostly it is area within that curve, within that bounds, right?
so
Okay.
the reason should be that the probability at one point fixed point is 0 for continuous.
That should not be the reason, right? Why it is this at the fixed point it is 0, that is correct, but on and around that point the values are different, right? So we'll define the probability actually for the over the small interval, right? Over the small interval, so that interval may be very small, but if you find the probability on the some point, that will be 0, right? Okay, let's check it out, like maybe
So that is why less than or equal to same as less than.
correct. Okay, let's see whether it's correct or not. Option C. Option C is correct or not?
Wrong, sir.
Wrong. Now option D.
Correct.
Correct, correct.
Okay, so let's. Okay, I'm not sure. Yeah, all three are correct, right? All three are correct. Correct.
What can we do the next question? Sir?
Next one. This simple one. This is actually you
The
guys have
third
found it.
question. The third question. The amount of milk
The
produced.
amount of milk produced every day by a dairy is uniformly distributed. So it's about uniform distribution. 100 liters and 120 liters. What is the probability that the amount of milk produced is more than 115? given that on one day more than 100 of okay, this is
So
conditional
this is conditional probability, right?
okay, do you want me to solve this? Okay, anyway we haven't seen that, so maybe I'll solve that question, right? And then we'll see multiple continuous random variables. What is given there? The amount of milk produced every day is uniformly distributed between 100 and 120, right? So how does my PDF will look like? What is PDF for
1 upon B minus C.
B minus, right? So 1 upon B is what? 120, right?
120 minus 100.
1 by 20s.
1 by 20 is PDF. I wanted to find
Okay.
what? Probability that uh, more than 115, given that one day more than 110 is, so probability that x is greater than 150, given that x is
Greater than 110.
okay. So how to find the probabilities? This is probability that x is greater than 115 and x is
Greater than 110.
okay, divided by probability that right. Okay, but if you see this is what is nothing
Same
but
as x is greater than 115.
right. This is called okay. How to find that probability that x is greater than 115? So this is nothing. Probability that x is greater than 115 is nothing but 1 minus probability that x is
Less than
115. So it is 1 minus f of 15, right? Okay. So first of all, what I have to do is I have to find f of x, which is here in this case, what is it? It should be
a
100,
to x.
100 to a, right? 1 upon 20.
So 100 to x.
Okay, x. Yeah, let's sorry. Yeah. So this is 1 by 20. That's nothing but what? X minus 100.
Yes, sir.
X minus 100 by 20, right? So here I'll say 1 minus 115 minus 100 divided by 20, which is 1 minus
5 by 20.
yeah, 5 by 20 is 1 by 4, right? And it's 1.25, right?
Yes, sir.
Okay, okay. What about probability that x greater than 110? This is nothing but 1 minus f of 110. So I'll be just writing 1 minus 10 by 20, something but half, right? Right? So if I'll plug in all these values here, I'll get 1 by 4 divided by 1 by 2, which is 1 by 2. Is it okay? This is fine.
Yes, sir.
Okay. So yeah, let's move into multiple random variables. Okay. So
Sir, can you show the answer to the previous question? Sorry, just
yeah, yeah, fine. No issues.
Okay, sir. Okay.
It's fine. Okay, right? Until that this point. Right. So let's go to the joint PDF. So joint PDF of a bivariate random variable is given here. Here C is some constant, and what will be the value of C? So f of xy is given as this, right? This is, and we have to find the value of C. Okay. So joint PDF. So you can actually relate it to what we have seen in discrete random variable case, but here the only uh, changes here we are dealing with continuous random variable. So C to xy square, and x is between 0 and what is the range of x here?
0 to 1.
1, and similarly the range of y is 0 to 1. Now what is the property that we have seen in multiple continuous random multiple discrete random variables is, or so if you add all the joint probabilities, it will be sum up to what? 1, right?
Yes, yes.
Right, all the joint probabilities, if you add, it will become equals to 1, that we have seen. Similarly here, if you add all the joint probabilities, and adding here it means what, in case of in terms of continuous random variable, it's
And
integrating, right? So if I integrate uh, all the values here, so I have to integrate for x equals to 0 to x equals to 1, and y equals to 0, y equals to 1, or you can add like otherwise, uh, and c into xy square, what is here, dy into
dx
dx. Okay, and that should be equal to how much?
1 1.
1. So let's do the integration here. So it's 0 to 1. What will be the first value? C outside, since it is a constant. This is xy to the whole square. That means actually it is like this, right?
X
X
square y
square,
square.
x square. So here we are treating x square as constant, right? Because we are integrating with respect to y. So cx square, y square is what? Y cube by
3
3, 0 to 1
to 1
into
dx.
dx, which should be equals to 1. Now the next step will be okay. So I'll add one more step. So 0 to 1 is cx square. This is what?
Y cube.
1 by 3. I'll put the limits, right? So it is 1 by 3 minus 0, right? So I'll put 1 here, upper limit 1 by 3 minus lower limit 0 by 3. It is again, so it is 1 by 3, right? Dx is equals to 1. Okay,
Okay, okay.
this is fine, right?
Yes, yes, yes.
Okay, then what about it? So c into 1 by 3 are anyway constant, so I'm just putting them outside. C by 3. What is the integration of x square?
It will be 1 by 3 again.
Yeah, which is x by 3 from 0 to 1, which is equals to 1. So this will become c by 3 into 1 by 3, right? 1 by 3 minus 0 against 1 by 3 only, which is equals to 1. So this will be c by 9 equals to 1. So which will get c as
9.
okay. So suppose I put c equals to 9, I should get this value equals to 1, and I think that is correct only, right? Right. So my joint PDF will look like this for continuous random variable as 9 x square y square between x is between 0 to 1 and y is between 0 to 1 and 0. Done. Is okay. So let's check the answer. It is 9. Correct only, right? How to find marginal? Now this is my CDF. I'll talk about the marginals here. So now my fxy is equals to 9 x square y square, and this is the thing. If I wanted to find f of x and f of y, what we did for discrete random variables, when we found out the marginals, we have kept x as constant, right?
Yeah.
And we have added all the values of y,
Why?
right? So here, if I wanted to find f of x, then that means I have to integrate with respect to what?
Why?
Why?
Y, right? So f of x is equals to integration. It's in this case, okay. I'm just talking about in this case. So this y equals to 0, y equals to 1. So limits are from 0 to 1 for y. Then fx y with respect to y. So that is nothing but I'll say 1 fx y is 9 x square y square into dy, right? This is okay, because you see, you remember about multiple discrete random variables. What we did was we were adding the joint probabilities, right? Where we were adding joint probabilities by keeping x constant, right? When we found out the marginal densities, that same thing we are doing. We are keeping x constant here. We are integrating with respect to y. So okay.
Okay.
So how to find it? Like 9x square, since x square is
We are
constant.
treating y as a variable.
Yeah. So directly writing the answer. So 3x square is a marginal here. This case. Okay. Uh, what about fy now? Integrating with respect to x, and that will be okay. Just take your time, think about it, and let me know if it is fine or not. Okay, this okay. Ah, okay, you guys are silent. What is that?
No, it's okay. It's okay.
It's fine, right? Okay. So let's move towards this one, the conditional. So fx given y. How to find this?
F of x union y upon fy.
Yeah, generally it should be like this, right? For our case, right?
Hmm.
For general case, for multiple discrete random variable case. In this case, what should be fxy of so yeah, this thing. So what is fxy? 9 x square y square, right? This is the joint density, right? It's fine. And what is fy? It's 3y square. So fx given y. So the conditional distribution here it is 3 square. Okay. And f y given x is what? F xy divided by f of x, and this will be 9x square y square divided by 3x square, and it will become 3y square. So you can notice one thing here, the fx, right?
Independent.
Yeah, 3x square and 3y square. the same conditional distribution you are the conditional distribution for x given y is equal to f of x, and conditional distribution y given to x is equals to f of y, and that is actually a you can say that they are independent, but the correct definition is what, this one, fxy, it should be of, right, and you can say that 9x square y square is nothing but 3x square into y square, and hence they are independent, and if they are independent, then their conditional distribution, so f x given y is nothing but equals to f of x, and f y given x is nothing but equal to of y. Since they are independent, what is happening here, the condition, because see conditional will so given x, right, so this distribution does not affect the distribution of y, right, the distribution of x does not affect the distribution of y, and hence we are getting this relationship here. Is it okay?
Okay, okay.
Yeah, maybe you guys have to do like little more brushing up, maybe, because like after like long time I think you guys are seeing this one. So okay, can you how to find out expectation of, okay, I think I don't know, okay, I need to check whether it is there or not.
No, so CDF is not required in this case.
So,
In case of joint distribution.
CDF generally you don't need to find, because anyway you can find it out, but generally uh, it's not needed, because individual, okay, I don't know how to tell. CDF is what, provided
CD,
that uh, i- since you are having the joint density function,
yeah,
you don't need to find out the individual probabilities there for finding out the values of x, because joint density is kind of an intersection of two random variables, right?
yeah, yeah.
So you can find it out all the values of the probabilities based on the joint density function itself, so individual CDFs are not required there. Okay.
Okay.
Okay, one more point here is uniform exponential normal. Okay, I don't know like what to explain there. Maybe I'll give you the formulas, and maybe we can close it, and if you have any doubts you can ask in the next session, right? So uniform distribution is uniform continuous. What is PDF? I think we have seen it already. What is PDF of uniform distribution?
1 upon something, 1
A
upon
minus A,
1 minus b.
and within this interval, right? A
Yeah.
and B. Okay. What is CDF?
X minus A upon B minus A.
B minus A, right. What is expectation? Dx, right? I think this one, let's say 0 dx. I don't know. Like, or 9. Oh, sorry. It should be from A to x, right? So it is what? X square by 2.
Sir, expectation should be from A to B.
A to B, huh? Okay, yeah. Yeah, right. So here it should be B square minus A square upon 2. So this is B plus A by 2, right? A plus B by 2. Find it? Okay, maybe I'll write it down. So yeah, so this is x square by 2, right, from A to B. This one upon B minus A, since they are constant. This is B square by 2 minus A square by 2. Here it is 1 upon B minus A. Okay, and and I can say it's b square minus a square by 2. Outside it is 1 upon b minus a. But a square minus or b square minus a square is nothing but what? A plus b, or I can say b plus a into b minus a. So this will get cancelled and you'll fine. It's okay. I can directly write expectation of this a plus b by 2. Okay. Uh, let's find it out. Next one as exponential. What is PDF? Oh, sorry.
It's Poisson.
Sorry.
Poison, sir.
Yeah, sorry. Right? This is PDF, then CDF is, I guess, what is it? 1 minus e to the power lambda x, right? Expectation. Expectation will be, I think it is 1 upon lambda, right? Okay, I didn't find out.
Yes, sir. Yes, sir.
Yeah, and then variance. Okay, you
1
need
upon
the,
lambda square.
you don't need the proof, right? I think you can find it out yourself anyway. So, right? Yeah. Then we have normal distribution. For that we have PDF as this normal. I will write it as like this, right? Comma sigma. This mean, this variance. In that case it is 1 upon 2 pi sigma e to the power minus exponential to the whole square upon sigma square.
Sir, what's that symbol with the sigma in?
Standard deviation.
Yeah, no, the one with it. Mu, is it mu?
Bias.
Mu. Mean,
Mean,
right?
sorry.
Mean. In case of this is exponential divided with respect to lambda, right? Okay. These are, and okay, mean and standard deviation is already there, so
We
we
have to
only,
remember this all.
these are simple one enough. I think you can remember, or I'm not sure, like I will check with the team that if it is required or not, because
I think it's required to remember it, or you can check in the stats too, like during the exam.
yeah, there also I'm not sure like whether in
But in stats too,
MLF
we
there.
had these formulas
Yeah,
given.
you can check it from there itself. So I'm just
Okay.
writing it down here. Anyway, these are not that difficult to remember, right? These are very simple formulas.
Got it.
At least you should remember PDFs, right? Then you can find out CDF and expectation easily with the formulas. Okay.
So in the exam, do you
Okay,
give
sir.
the
Okay. Then
formula sheets?
that's what all of them are saying, that you will get in
We can refer
stats too.
to
So
stats.
you
That's
can
it.
refer stats too.
No. What I'm asking, like stats too, will you give formula sheets for this exam?
That I'm not sure about, but I'll check. Like I'm not sure
Mostly
that because I'm
yes.
not. Yeah.
Too
Yes.
many formulas, sir. You'll forget it and will mix up.
Uh, that's what you can check it from stats too. Stats too it is given, right? I think
Yes,
all the
stats too it's
tabs.
given, but I'm asking for
No,
the
no, but
exam.
all the in the exam itself, you will have a lot of tabs, right? You will be toggling between the tabs, right? So let's say you have two papers,
You
question
can just
papers.
go through stats
Go
too
to
and
the
just check
stats,
formulas from there. That's
check
it.
the formulas. That's what.
Okay,
But
sir. So
will it be
regarding the
there?
PT
Yeah.
weightage,
Okay, weightage. I'll stop recording first. And then,
Sir, is this it for week 12? Week